Well, good to the introduction will be from my side, and then we continue straight away to the global dairy farmers and to our speakers of this evening. For us, it's evening. For our friends in Canada and US, it's in the morning there. Good to know for each other. Well, thank you that you all are coming in right now. We are very great to have John de Jonge and Brandon Peterson here on to tell something about actually a new way of growing feed roughage for dairy, for cattle. And Jeroen and we already heard, we have already seen some presentations about it, and we are very enthusiastic. And we thought that this is really a story which our students also should know about. So yeah, we are very pleased that John and Brandon can tell something about this. And we are also very thankful for Yvonne Ossefort. She is from the organization of Global Dairy Farmers, Aeres, our school, and Global Dairy Farmers. We cooperate on several subjects. And Yvonne, she's actually the host at this moment. She organized this seminar for all of us. So yeah, thank you, Yvonne, already ahead for this. And I think we go now to Yvonne. Yvonne will tell us on the technical things about the seminar. And after that, we will continue, and then we hear the story where we're coming for this evening, the story of John and Brandon. Yvonne, it's up to you now.
Thank you very much, Jan, for this introduction. I hope everyone can see me. Yes, yeah. I think so.
Yes.
Jan, I think I'm gonna mute you.
Okay.
Yes. Okay. Hi, everyone. Welcome to this webinar. A webinar especially for you guys. We had great discussions with Jan and Jeroen, and also with today's presenters, John de Jonge and Brandon Peterson. As Jan said, my name is Yvonne Ossefort, and I'm actually the operational manager of Global Dairy Farmers, and I'm today's host. So for those who are not yet familiar with this software or this application, Zoom, I'm just going to give you some details about the functionalities and to answer Celine's questions. So, yeah, there we go. So that's called a little bit of housekeeping. First of all, this webinar will be recorded. So that means that by tomorrow, you will have a link. You can watch it again, or your students who are not able to join now can also watch it later on. And I'm going to talk about the other functionalities and also about the outline of this webinar. So, webinar participation. At the bottom, you see chat, raise hand, and Q&A. And for this webinar, only raise hand and Q&A are enabled. So that means if you click on raise hand, you see it here. Maybe you can try it all now. Can everyone click raise hand just to see if it works? If everyone can see it. I don't see any hands raised. Can you click at the bottom? No, is it not working? Maybe someone can type in a question at the Q&A if it's working or not, the raise hand functionality. You raised your hand. Okay, perfect. Yeah. Perfect. Yes, here it goes. Okay, perfect. Okay, perfect. Thank you. Thank you. Very, very active. So let's raise hand. Then there's the Q&A box, and I think most of you figured it out already. You can type in your question. You can send it anonymously if you want to. Type your question and send it. Perfect. And just before we actually start the real presentation, I just want to ask you a question during the use of this poll. Because I understood from Jan and Jeroen that you're actually talking about these topics as well during your classes. So just the first question. Can you see this one? This poll? Yes. So I quickly see the answer is, will vertical farming result in less artificial fertilizers? At the moment, it's approximately 70%, 70% that says yes. Yeah. Great. I think that's, yeah. So 75% says yes. Let me end the polling. Here you go. And we have another question. To grow feed under conditioned circumstances in the Netherlands can be an improvement. Do you agree with this statement? You can vote. It's a question that came from your teacher, Jan. I see people thinking a lot, so it's a good question, Jan. It's interesting to see what you guys are thinking. So a couple more seconds and then I'm going to end the poll again. Yeah. So here you see the results. Half of you say yes, because also under Dutch circumstances, we can produce on an efficient way more feed. And the rest is divided by the other answers. Great. So now you know a little bit of how the functionalities work, and we know a little bit how you think about certain topics. So our talk of today, I'm going to shortly introduce you to our organization, Global Dairy Farmers. Then we have John de Jong and Brendan Peterson do the main presentation. And during the presentation, there will be a moment of Q&A where we'll have a look at the questions you type in the Q&A box. And I will read out those questions to either Brandon or John. And, oh, excuse me. Then we have the panel discussion, where you students have the opportunity to actually go live and either ask your question live to John or Brandon, and maybe they have some questions for you as well. And I know that Jan and Jeroen will pick out the students. There's a spot for 3 students. And after that's done, then it's time for the closure of today. So Global Dairy Farmers as I said, I'm the operational manager of Global Dairy Farmers, and what that means is that I connect our dairy farmers, our members, with our business partners. And it's quite a unique network because if you have these people all in one room and they're from every part of the world, the amount of knowledge is incredible. And they're very open, they're very honest. So what are the learnings? What didn't go right? What did they learn from it? And what opportunities do they see? What's happening in the world? How is that impacting their farm? How is that impacting all the processes they have and have to change at their farm? They're very future-oriented, very progressive. They're leaders of their country, of their farming network, and we organize several events to get all those people together. Right now, it's more online, obviously, but we have a main congress once a year and several other events. And with those dairy farmers, we have business partners. And that's where John also gets in. So today's presenters, John de Jong and Brendan Peterson, they will talk about indoor controlled feed production, the future for sustainable dairy. And let me just shortly introduce these two very inspiring speakers. First of all, John de Jong, he grew up on a farm in Canada. And I think it was, I'm sorry, John, for this, but he bought Artex Corn Solutions, I think maybe even before you guys were born. And he knows all about barn equipment, the cow cooling, cow comfort, and he's the president of this company, as well as the president of Hydrogreen. And Brandon, he's, let me quickly check whether I'm explaining this correctly. Brandon and his wife are owners and managers of Peterson Angus, 350 head registered Angus herd in Dakota in the US. And next to that, he's a product developer for Hydrogreen. And I think before I give the word to Brandon, please raise your hand, students, to give Brandon a warm welcome. Brandon, it's up to you.
Well, thank you, Yvonne. It's an honor to be here, I guess, this evening for you guys. It's about 12:15 p.m. here. It's dinner time here for us. Like I said, it's an honor to be here. I'm going to hopefully challenge your skills in English, or maybe help you listen and understand here as we go along. The future of nutrition production for your dairy, or for a dairy, is the topic we want to just touch on briefly here today. So some of the challenges that we see with traditional feed production, and I think everyone will recognize these very quickly. I'm here on a sales trip in Utah, which is a western state in the United States, and they're always in a drought. They're dry again this year. They're almost out of irrigation water. By the end of July, there will be no water left for many of these farmers to continue to grow their crops. So they expect to not be able to finish growing their corn crops and their hay crops this year. For a lot of parts of the world, we have snow and ice. We have winter. They get one crop per year. And also the moisture in some parts of the world leads to harvest problems, feed quality, feed stability. The other interesting thing is a lot of the parts of the world that have a climate that's suitable to grow 2 crops per year struggle having enough water to grow 2 crops per year. They have a long enough growing season, but they don't have the water available to them. And that's a global problem, not just here in the United States. The other things that are going on right now in the industry is the consumers are changing the way that we produce feed, or produce the food that they consume, between regulations, restrictions, and then this buying power. They're voting, consumers are voting with their dollars. I want this on my label. I want my food to be raised in this manner. I want it to be sustainable. I don't want there to be a carbon footprint. I want everything to be renewable, all natural, non-GMO, grass-fed. You can go on and on with different label claims we see continuing to pop up and become really more prevalent and more important each and every day to the consumers that, as farmers, ultimately give us our money. If our products don't sell to the consumer for meat, milk, eggs, on and on, if they don't vote with their dollars and provide money, then as farmers, we cannot continue to do what we do. So everything we produce is tied to their demand and what they want in some way, shape, or form. So here I have a really quick video. It's a 4-minute video. I apologize. It doesn't always play the cleanest, but usually the audio works really good. So you can listen, you'll see pictures of our system. If the video is not smooth, you'll be able to see the pictures of our system, and you'll be able to see pictures of what we have going on. We'll provide this link for you after the video, and you guys can download it and watch it in a little bit better format.
So welcome to the Eco Dairy Hydrogreen Grow Room. My name is John DeYoung. I'm a partner at the Eco Dairy and also the president of Hydrogreen. Let me take you on a small tour here of our grow room. In this grow room, we have 2 6-section machines, which are here to grow 6-day-old wheatgrass, which we feed to our dairy cows. And also we have a grass-fed beef program here at the Eco Dairy. What we have here is 6 different layers, 1 for each day of growing. It goes from 1 pound of seed to 5 pounds of feed in 6 days. So here at the end of the machine, we have our very simple land on a stand control panel. Very simple touch screen, which controls the harvesting, but also the watering. We can adjust any of the protocols of the machine right here from this panel. And this is integrated into the PLC back at our head office, where we can help the farmers really manage their facility. They simply are a conveyor belt, as you can see along here, with a roller and a drive mechanism. We use water controls, lighting controls in a simple conveyor. When the product is grown after 6 days, we activate this motor, the material winds up on a roller, and it drops on the table when it goes through the cutters. Once the system is now then harvested, the belt is clean, into automatically and returned, and it automatically seeds. That's how simple the system works. And as farmers and users, this is what we like about the Hydrogreen system. We're able to take 15 pounds of dry matter into the sophisticated dairy ration, and we're really learning what that can do to the rumen of the animals. So advanced feed technology is a real new component of feeding this controlled environment animal feed to ruminant animals, being beef and dairy. One of the benefits that we saw already 3 years ago when we started feeding this Hydrogreen product to our beef and dairy animals was the health benefits to these animals. And what we found is no matter where you are on earth, you can feed fresh, green, lush, nutritious product to these animals 365 days of the year.
My name is Bill Vanderkoy. I'm the farmer at the Bakerview Eco Dairy here in Abbotsford, BC. This farm is used for both producing milk as well as for agritourism, where we teach people where their food comes from. As you can see in this ration, it's a total mixed ration, and we've incorporated Hydrogreen into the mixture. We're also currently doing a trial where we're replacing some grain in the diet with Hydrogreen, as well as some forage in the diet with Hydrogreen. And then in between that, we've got a control diet so we can measure differences in performance, production, and health. So far, at the early stage of the trial, we're seeing some positive benefits on performance. So here at the Bakerview farm, we're raising grass-finished beef. They're Angus Holstein crosses. And we're using the Hydrogreen as part of the finishing diet. So in this TMR, we have grass silage and Hydrogreen. And we're finishing these cattle They're all steers, and they're finishing grading at AAA, which is really impressive. And we can do this year round because we're using Hydrogreen as part of this diet.
So there you see a brief look at our system and what it looks like, how it operates. I apologize, like I said, for maybe the video quality not being the best. We will get you that link and you'll be able to watch it in a format that you'll be able to hopefully see and play smoothly. I also apologize for pausing it there. I clicked on something I shouldn't have, but so what we're working on here at Hydrogreen is producing fodder. Now, fodder is not a new idea. It's been around since at least the 1600s. They can find records of it. So this is not a new technology, but there hasn't been a lot probably invested into this technology until the last few years. It used to be done only in trays where you'd put the seed out, put your trays in and water them, and then in 6, 7, maybe 9 days, dump your tray and you'd have your feed for your livestock. Very labor intense, very difficult to do. So thus limit the amount of scale or the amount of animals that you could feed unless you had a huge labor force there. Currently, dairies love the feed, but they hate the labor. I've got about 25 dairies here just in the state of Utah that are feeding fodder through a tray system that I know of that we're calling on right now. And like I said, they love the feed and what it's doing for their livestock, but they hate the daily chore of raising it. It used to be a one-size-fits-all approach. Fodder is not a silver bullet. The old way of selling this system or these types of systems were buy this, put the seed in the trays, and just feed all the fodder that they'll eat. This is the only thing they need to eat. Well, that's not necessarily true. Fodder itself, and we'll talk about the nutrition in just a few minutes, is only an ingredient. It's part of a balanced diet. And when we balance that diet, there's a lot of really positive effects that we can do by adding this particular ingredient. There's some management that's needed to produce really good feed or proper dry matter, like any other crop you would grow in a field. We use state-of-the-art automated technology. It's a fully automated system, so we harvest and we seed with just the push of a button on the touchscreen. It's simple to operate. No additional harvest equipment necessary. We don't need swathers or combines or wagons to haul things in from a field. The feed is produced fresh every single day, and we don't really need any special feed storage. It's going to go on an auger or a conveyor when it's done, and it's going to conveyor to your feed wagon or to a bunker or a pile so you can scoop it up and feed it either in a feed wagon or feed it directly to the livestock. There's no preservatives needed. In our system, we use water, seed, and light. We grow for 6 days. That's why our system has 6 levels. We harvest 1 level each day and reseed that level. So water, seed, and light is what we're using for our feed. We get about 6 to 8 inches of fresh feed every single day. And it's really a one-person operation with very limited labor needed. There, as you can see in the video, very few moving parts. So that belt that you can see that was growing the fodder only moves for about 24 to 30 minutes once every 6 days. So there's not a lot of things to break or go wrong. So what is it? What's the nutrition that we're growing here? No, when you sprout a seed or germinate a seed, you're changing the digestibility drastically. So if you take a wheat seed or a barley seed, if my fist is that seed, you take either of those, and we can grow almost any kind of seed on there, but wheat and barley are the most common, and you put water on them. Well, to start with, that dry seed is about 62 to 65% digestible. Once you water it and it starts to sprout and grow, it's going to be about 95% digestible. There's natural enzymes, the hydrolytic enzymes that start to really digest that seed from within and allow it to grow, allow it to put that root out and the foliage on top. Those hydrolytic enzymes that are helping it grow are digesting that seed. Well, those natural enzymes are available when you feed that plant to your livestock. They're going to go inside of the rumen, and they're going to help digest the total ration, or the TMR that you're feeding the cattle, the total mixed ration. So you get some additional digestive efficiencies across all of the feed that you feed the animals. It's high in energy. It's about 96% the energy of the original parent seed. So if you're using wheat to sprout, you're basically feeding the same energy as wheat itself would be. The same with barley. It's a high quality protein, about 2% more protein than the original seed started with. So if you start with a low protein seed, you're going to have a small increase in protein. If you start with say a 15% protein seed, you're going to have about a 17% protein feed. It's high in phosphorus. So if we look at the 3 most expensive ingredients for most parts of the world, it's going to be energy, protein, and phosphorus. The neat thing about fodder is that it's high in all 3 of those. And then the germination process will naturally chelate the minerals that are in there. We recommend about 20 to 25% of the ration dry matter come from fodder, or Hydrogreen in this case. So a typical wheat analysis is going to be about 18 to 18.5% protein, but it's only as good as the seed you start with. So if you have a low protein seed, you won't have 18% protein. That'll be about an 85 NEL, or net energy for lactation. It's going to be high in sugar, so 30 to 32% sugar, about a 0.42% phosphorus, a 20% NDF, and at least about 23% dry matter on wheat. Your barley dry matter will be a little bit lower than that. We typically see 17 to 18% dry matter on our barley. That's kind of one of the big reasons we like wheat as a parent seed or a germinating seed. It's a great fit for dairies. To kind of review, it's an important ingredient in a well-balanced diet, but it's just that, it's an ingredient. It's not feed all of this and all these great things are going to happen. There's almost no waste or shrink. When you harvest and it goes in a pile or goes in your feed wagon, you're not going to have a bunch of spoilage there, and you're not going to have something you have to throw away. It's feed on demand, nutrition on demand. And because of all the moisture in this feed, it's a great ration conditioner for dry rations, basically. If you're feeding dry hays and grains and you don't have a lot of moisture, this feed's going to go in there and really help everything stay in mix, but also take the dust out of the ration. It's a high quality, consistent nutrition on demand. So you were seed to feed in 6 days. The germination process is converting the starch in the original parent seed to sugar. It's going to go from a grain to a highly digestible forage. Like I said, it changes the digestibility from about 65 to 95%. And we're seeing a 2.5, maybe even as much as a 3% increase in protein. We can add more protein to the ration by the seeds that we decide to germinate. If we found some soybeans, some field peas, something like that, we can easily raise a feed that's about 25% protein. So now it can become a significant protein contributor to the ration. It's almost identical. It has an almost identical energy profile as the parent seed did, and it's going to reduce the metabolic stress in the animals by lowering the starch load. So that germination process is converting the starch to sugars, but leaving the energy the same. We can make really nice rations with a much lower starch load on those animals. And this is what's going to lead to improved animal health. So we've got just a really short break for 1 or 2 questions. Yvonne, if we've got any questions so far, otherwise we can push forward here.
Yeah, sure. Yeah, there are a couple of questions, and I think you already answered one of them. Linda asks, what kind of fodder is it? Grass or wheat or something else? Or can it be done with more than one thing?
So I can expand on that just a little bit more. Like I said, wheat and barley are the most common. Traditionally, fodder, at least in the United States, is barley. But we've done seed blends of almost anything, oats. We do flax. Sometimes we're doing studies on changing the omega-3 and 6 fatty acid profiles to manipulate the meat, milk, and eggs that our producers grow, at least what those amino acid profiles look like. Field peas, we've done some with alfalfa seed in it. For the most part, there's not a seed that we can't grow. If we get to a waxy coated seed like corn, it takes a little bit longer than 6 days, at least at this time. So 8 days maybe, well, will work really good for corn. But 6 days on most of your small grain seeds and other small seeds.
Thank you, Brandon. I think one more question, but it's a combined question from Jacob and from Celine. Jacob asks, where do you get the seed for the fodder? You still need crop farmers. And from Celine, relates to it, so how sustainable are the seeds produced?
Yep. So those are great questions. Yeah, we still need crop farmers, and I don't, you know, in a bigger picture, hydroponics is never going to replace all of the land that we use. I mean, there's still going to be needs to have traditional farming. This is just going to be another means to successfully grow and really better control the nutrition you provide your animals. But we still do need a certain amount of seed each and every day. Most of our guys are either contracting with local farmers, or they can go buy on our seed cleaning system that we have with our system allows them to go buy on the open market, typically from farms, but can be from other elevators or cooperatives that would sell seed. We don't need certified seed to make this work. That's part of the reason we have a really good seed cleaner involved in what we do.
Thanks, Brandon.
So here's, yeah, anything else there, Yvonne?
No, sorry, continue.
That's okay. So here's the phase that we've just entered, and we're starting now as a company. So the company itself, Hydrogreen, is about 5.5 years old. Our oldest systems that were out in the market are almost 4 years old right now. We're in the testing, improving, and really the scaling up phase right now. Here's some of the things our customers see right now: are higher pregnancy rates, lower dry matter intake, so better feed efficiency, increased milk production, improved herd health, and improved milk fat. So these are the things that we have to quantify and be able to put real science behind and demonstrate, not just on the farmer down the roads. He says, oh, I get better pregnancy rates. Well, he's feeding all of his cows Hydrogreen or fodder. So we're in the process of testing and proving this and developing this out. One of the projects that's going to do this for us is a project for 800 milk cows. We're going to feed 800 head fodder or Hydrogreen, and we're going to feed at least 800 more on their current traditional conventional ration that does not have any fodder in it. This system, the systems run top to bottom on the screen. The system has 18 systems drawn in there in this building. We're going to put 14 of them. We're going to start with 14 systems in this building for testing and trial purpose. And those 14 systems will produce about 67,000 pounds or 30,000 kilograms of feed every day, 365 days a year, even when they get a blizzard. Since we're inside every single day of the year, will be about 30,000 kilograms. It's going to produce 15,000 pounds of dry matter, or about 7,000 kilograms of dry matter each and every day. This dry matter would replace almost 300 acres, which I think about, or 121 hectares of corn silage. So in this footprint, we can replace about 121 hectares of really good corn silage. So the project itself, the building is 234 feet long and 80 feet wide, which is about 71 meters by 24 meters. It's a total square footage of 18,720 square feet, or just over 1,700 square meters, which I said compares to 300 acres or 121 hectares. The other things we're able to do, you'll see obviously we're weather independent. We're providing some turnkey solutions for our customers, but really this is the point I wanted to show you guys. It's scalable from one system to 1,000 systems. So it works for small farms or large farms. Here's some example buildings in the top left-hand corner of one system, two systems across, and then down to the bottom, up to 6 systems in one building. They're fully engineered, fully automated, and you're going to get your consistent fresh nutrition every single day. So what about sustainability and the consumer demands? How do we meet their expectations that they're placing on us, which really as farms continue to go up or increase each and every year? Where have we been? Where are we going? So the neat thing about fodder, we're going to reduce feed miles significantly. Our systems qualify for carbon credits. We've got a carbon credit study that was done up in Canada. Across Canada and the United States, there's different states and provinces that do offer carbon credits. Our producers would qualify for carbon credits using this system. We're not burning diesel fuel to harvest or store the feed. It's really easy to produce seeds that are non-GMO or organic, or produce a feed that qualifies as non-GMO or organic. And then we have a huge water savings over traditional crops. So here's just a little bit about the water. It's one slide. I apologize, it's in gallons and not liters, but it's the scale of it is going to be exactly the same. So this is the number of gallons it takes to produce 1 pound of dry matter. If you're going to grow alfalfa hay, especially irrigated alfalfa hay, it's going to take about 45 gallons to produce just 1 pound of dry matter of alfalfa hay. Corn silage is 26 gallons of water to produce 1 pound of dry matter, but with Hydrogreen we can use about 1.3 gallons to produce 1 pound of dry matter using a Hydrogreen system. So Hydrogreen's putting you in control of your feed, your farm, and your future. So we got time for 1 or 2 questions here, Yvonne. If there's any here, then turn it over. Then I'll introduce John and turn it over to him.
Okay, thank you. Yeah, there are a couple of questions. Karen, she asks, what's the percentage of dairy farmers that is already using this kind of feed for their dairy cows?
So I don't know if I have accurate numbers that it won't be huge, but when you look at it globally, where fodder is already more accepted, especially in some of your more drier climates, I'm going to guess it's going to be no more than 1 or 2%, just thinking about all of the other places around the country that do that. But I'm going to say 99% of them are going to be manual tray systems. So they're going to be smaller producers that are probably doing all or most of the labor themselves. And 1% might be high, because when you look at the really large dairies that are looking at our technologies now, but they're not using them yet, or they're just starting to use them as we're building buildings.
Thank you, thank you. The questions keep popping in. So let me just pick one more question from Wesley. Is the water that is needed for growing the grains included in the 1.5 gallon of water that is needed?
That is not. That is just for growing the feed or the fodder itself. So the water for growing the grains would be additional to that. Now the nice thing through our system, we're getting about a 24% increase in dry matter in just 6 days. So we're getting a little bit further efficiencies with those waters, in addition to water that we might have used to produce the seed itself. And then really that water that helps us transform the nutrition into a more digestible, a more usable, and a little bit better product than what the original seed was.
Thank you, Brandon. There are more questions, but I think it's time for John to take over.
Yeah, so our next presenter is Mr. John DeYoung. He's the Chief Design Officer of Cubic Farms. As Yvonne, you stated earlier, he's the owner of Artex Barns, the president of Hydrogreen Global, and a member of Global Dairy Farmers since 2008. And probably the most exciting, and probably the reason that the two of us are working together now, he's been a Hydrogreen owner. He bought the first systems that we commercially produced almost 3 years ago now, I believe. Since then, they've bought 2 more systems and are using them, as you saw in that video, on their dairy there near Abbotsford, Canada. So John, I will give it over to you. Probably have to unmute yourself there.
Am I there now? Can you hear me?
Yeah.
Well, thank you, everyone. First of all, it's an honor to be speaking with you all today. I've known Jeroen and Jan for some time now, but Jeroen for more than 10 years. And we've always admired each other's commitment to developing new ideas in the dairy space. So very proud of one of your instructors. We've known each other for a long, long time. Hopefully you can see a rendering of a dairy farm. And what I want to do is just give you a really quick little walkthrough of this dairy farm. And many of you, or all of you, have experience on dairy farms and have family dairy farms, as I do as well. As Brandon said, we've had a dairy farm for many years. And in 2008, we built a robotic dairy farm in Canada. We put an anaerobic digester on the dairy farm because we felt we had to learn about sustainability in the future. And where I live, land is very expensive. So where I live, I'll convert it to hectares. Euros per hectare would be approximately 150,000 euros per hectare is the cost of land where I live in Western Canada. So obviously we have land issues. So we did our best to build a futuristic sustainable dairy farm in integrating new technologies, anaerobic digestion, nutrient recovery, and then 3.5 years ago, as Brandon said, we installed 2 hydrogreen systems, and we're always trying to find better ways of dairy farming. So beyond that, I've also been blessed with working in 50 countries. We've just built a dairy farm in Qatar for Baladna for 14,000 cows. We work in Saudi Arabia, we work in China, Australia, New Zealand, and I've been very blessed to be very diverse around the world. And also I'm a very proud member of the Global Dairy Farmers who have helped educate me on the sustainable needs and the future of dairy farming. So what I want to show you as a group today is a very fun project we're working on, which actually happens to be in Europe. But for confidentiality sakes, I'll just say it's Eastern Europe because I'm not allowed to speak to you about details. But I want to talk a bit about what we think, so how integration of technologies could shape how we farm in the future in some regions. Very broad when I talk that way, but I want to take you on a quick little tour. So we believe that food companies, large food chains, the Nestle's and those types of companies will continue to want to be closer to the producers. So part of what our project here includes is on-farm milk processing. And when we go to the Middle East, almost every large-scale producer is already having a processing plant on the dairy farm. We cut out processing in terms of middlemen. We reduce the transport costs, and there's some efficiencies to be gained. But in order for that to happen, there must be some scale. So on this farm, you'll see the processing plant on the bottom. You'll see farm offices. And then on the left, you'll see rotary parlors. It's a little bit cut off, but on this particular farm, it'll milk about 12,000 cows plus dry cows. So there'll be a total of 13,000 cows housed in those 2 buildings, and 2 rotary parlors, each milking 100 cow rotaries. But what you're interesting to see here is you will not see a manure lagoon. So there's some developing technologies who we're partnering with that will process manure. You'll see the manure processing building in the center. Can you see my cursor here? Yeah. This is a manure processing building where the scraper system will bring it to a pumping system, and we're processing manure live 24 hours per day. And we're exporting dry manure where we are able to use technology so that the nutrients can remain in the solids, which is a unique technology where we can export dry nutrients with the equivalent of a 2-2-2, okay? Nitrogen, phosphorus, and potassium. So it's not a high-grade fertilizer, but there are nutrients remaining in the solids. We then are able to dry down the solids using the capturing of methane gas. So there's new technologies now available to us where we can take the air from the facility, capture the methane gas, use that as a fuel to burn and dry the manure. Not burn, sorry, dry. Burn the methane gas to dry the manure. So we're able to export dry products, and now that becomes a revenue that can be sold to landscape gardeners, cities, and get a revenue off the farm. We then take the inert, the clean water, the water that comes from the manure, and you'll see here, there's a Hydrogreen facility here. So the water that will be producing off the farm from the animal's waste stream will be growing up to 20% of the forage and fodder forage requirements for the dairy cows. Here we have traditional silage pads. Here we have a commodity shed. Another really, really interesting technology which we are exploring and plan to incorporate into this project, because we're using the methane gas to create heat to dry the manure, the remaining heat is captured by heat exchangers. Those heat exchangers then convert that energy through glycol into the side of these facilities, and we're using an air conditioning technology developed by a Dutch company. I cannot say the names, but you'll hear it very soon. And we're able to take this barn environment, and even in the Middle East, we're able to convert that energy from the methane gas and create an environment inside this facility of 14 degrees Celsius and 20% humidity. We struggle in California, in Texas, in Florida. The list goes on and on. Even in the Netherlands, the world, the environment, the climate is changing. My commercial business of Artex, even in the Netherlands and Germany and Europe, we're selling many, many more fans because the weather is, the climate is changing. So we're looking at this going, we need to use better resources to be able to create a better environment for the cows. And that's the world I've lived in for many, many years, trying to create a better environment for dairy cows. So when we look at the integration of technologies into this dairy farm, we see so many technologies working together. And we believe that's a very important part of our sustainability play into the future of dairy farming, which is a very important part of the supply chain in feeding the world into the future. So I'm very willing to open it up for some questions. Yvonne, you can take it back and answer any questions that might be of interest to any of the students, or maybe your own, or Jan even.
Yeah. I see you, Joost, asked a question. I think you already answered. Do you also use manure for the growth of the fodder? Well, and if not, where do we go with our manure? I think that's
fair enough. So in this particular facility, just for clarification, we're not actually putting manure on the fodder. And one of the reasons why is in 6 days of growth, all the nutrient required for that plant to grow is in the seed. We're just allowing it to come out. So the plant is not mature enough to uptake, even if it was to be liquid fertilizers or manure, because the growth is so quickly, we get no advantage putting nutrients on the plants. It's exported off the farm.
Thank you, John. Another question, a very practical one, is how many cows will one machine feed?
Good, that's a great question. And I think we're still under research and development. On our farm, we have 2 6-section machines to feed 50 milk cows. So our cows on our farm are young, but we're producing about 42 liters with younger heifers. So when we look at the kilos of dry matter intake and the percentages of feed, it's a hard answer. On our farm, it's approximately 25 cows per 6-section machine. On this facility, we have 18 machines to produce the material for 1,000 cows, but you'll also see we have planned, and it's shaded, to add another 10 buildings to feed all of these cows up to about 20% of the ration.
Thank you, John. I see Thomas is asking another question about manure. Can they reuse the manure for creating fertilizer and drinking water?
I think those technologies will continue to be advanced. So making a fertilizer, absolutely. Drinking water, there's still too many, the levels of salt are still a little bit too high in the offtake water, if you will. But I think as we gain traction momentum, and honestly, investment dollars. Because one of the things that's been short is investment dollars available to companies with technology that can get the proper money to explore different technologies. So I think that day will come. Today, using the manure water to go back to feed cows or for cows to drink, that technology is still under development. There's some companies that say they can do it, but on a commercial scale, it's still, that technology is not quite as advanced enough to where we are comfortable to use that on these farms. Hopefully I've answered that sufficiently.
Yeah, thanks, John. I see it's almost 9 o'clock in the Netherlands. Maybe it's nice to have a couple of students go live. Maybe Jeroen or Jan, you can let me know which students can take part in a live discussion with John and Brandon. So maybe John and Brandon have some questions for the students or the other way around.
Can they put up their finger or something that they...
Yeah, sure, they can raise their hand. Which ones want to go live? Or maybe it's...
If you think they're that shy in class, John, that's not...
I see Thomas.
I see Thomas raising his hand, so
yeah.
I think that might, that's okay.
Yeah, so Thomas is here. Thomas can turn on his video.
Hello?
Hi there.
Yeah,
I had a question. How is the society looking up against this system?
How is society looking up against this system? I think to honestly answer that, one of the things I have failed to mention is this design. Are you talking about the entire dairy farm, Thomas, or are you talking about just the Hydrogreen standalone?
The total, it's more like industrial and not like we used to, with the cows outside. And
I will say this, Thomas, we as a dairy industry are under siege by our customers and the consumers about our carbon footprint. So this dairy using these technologies has a negative carbon footprint. And when we speak to the Nestle's, the McDonald's corporations, we work with all those companies, carbon footprint, methane gas extraction, these things are critically important for our consumers in the future. But currently, technologies do not exist. So we continue to farm, as I do in Canada, with a traditional carbon footprint. When we go to large-scale farms in Texas and the Midwest, we have open lot dairies or open lot feedlots of 10, 20, 30,000 cows, and the carbon footprint is terrible. So we believe that carbon footprint, our carbon responsibility to the consumers in the future will be as important or more important to the consumers than the milk we produce.
okay, that's clear.
Time will tell, Thomas. We don't have the answers, but we are seeking partnerships with developing technologies to sort of do our part on the carbon, renewable resources, negative carbon footprint, net zero, those types of things. When you start to do some research, you'll see the large companies, Walmart, Costco, Nestle, the list goes on and on. It's critically important for them. So that's one of the big reasons we're doing this, Thomas. Hopefully that helps you.
Yeah, I understand.
Thank you.
Thank you for having the courage to put up your hand as well, Thomas. It took a lot of heart.
Is there someone else who would like to raise their hand and ask a question live? Or
and I think maybe Yvonne, I can add to Thomas's question. So you can see we're talking about Hydrogreen as a corporation and a potentially standalone technology to feed the cows on my dairy farm. better quality feed to increase animal health, milk production, those types of things. That's a wonderful story in itself. But where I sort of come in is when we build dairy farms in Indonesia, Vietnam, and Thailand, Pakistan, India. They're so challenged to feed their cows quality feed. But beyond the feeding of the animals, there's a much bigger play here. And that's sort of what I'm talking about. So the Hydrogreen is one very important component of a bigger story. And this is where it gets really, really interesting. So, you know, we as a company are very interested to partner with universities, with students to help us learn the real value of this technology. So that's where it gets really exciting for me, because we can develop the equipment, we can develop these technologies, but if it doesn't, you know, become profitable or sustainable for our family farms, or if it's not interesting or relevant to our consumers, we're just wasting everyone's time. So that's where it's really interesting to explore with the youth about these technologies. You can now go back to your classroom and go back to your families, and please continue to ask questions and teach us and guide us of the things you think are important for your family or your university or your region or your country. What technologies are needed for you to be sustainable? How are your families going to be farming in 10 years in the Netherlands? That's what we have to ask ourselves. What technologies are needed?
Thanks, John. I think that's a wonderful message to the students. You guys, you students, you're so important. Your feedback is crucial. I mean, John and his colleagues are designing these products, these services for the future. So for you guys, I think it's almost time. So let me just go to this one, because I think all of you students, all of you I think you deserve an applause. You can raise your hand to give yourself an applause, because the questions you asked, very challenging, very good, and a very, very special applause for Brandon Peterson and John de Jong for introducing us to this topic, and well, given your time and all your explanations. I think that deserves a great applause. So everyone, raise your hand for these two inspiring gentlemen. And I see I see the raising hands go up.
Lots of hands coming, yeah.
Yeah, wonderful. So I think it's time for the very last slide. Again, a thank you, and either, well, Jeroen, maybe you have a take-home message for the students, so some food for thought.
Well, I'm not sure if it's a take-home message, but yes, the question John said, how would you be farming or advising in 10 years? And well, if this is interesting, because we saw some questions, a lot of you will have their last year next year. So if you are interested in this topic or more international, please contact Jan or me. Because it's a really interesting subject, and we know that students also who could not join are interested. So if you are interested to go more into depth with this topic, don't be too shy. Is that a good take-home message? But
I think so.
Interested. And there's a big diversity in ways to raise good quality of feed with low CO2 prints or negative prints.
Thank you. Everyone, have a wonderful evening, and our two gentlemen have a wonderful rest of the day. Thank you very much for your time.
Thank you, everyone. Jan and Jeroen, thank you for arranging this. It's much appreciated.
Thank you.
Yeah, and thank you, Yvonne. and Brandon, John.
Guys.
Goodbye, everyone.
Bye-bye.
Goodbye.